The Mesopotamians built ziggurats and used them as observations 6,000 years ago. They originated the idea of dividing a circle into 360 degrees and subdividing each degree into 60 minutes, and in every minute to 60 seconds. The Mesopotamians created the 12-month calendar. While creating a calendar, they had to create an extra type of year to entirely divide the days, which we know as a leap year.
The Egyptians were around in 4000 BC, the same time as the Mesopotamians. The Egyptians used astronomy for practical purposes, such as developing a calendar to be used to predict the Nile flood and in aligning temples and monuments. No evidence of what the Egyptians really did survived.
Construction started in 2600 BC. The owner was Edward Seymour, the first Duke of Somerset. Constructed in three phases, and the age is estimated at 3100 BC. The Stonehenge we see today is the final stage, completed about 3,500 years ago. The Chinese created and recorded observations of eclipses in the 13th century. The record survived for about 900 solar eclipses and 600 lunar eclipses that were recorded over a course of 2,600 years. They also recorded other astronomical events such as meteor showers, guest stars, also known as shooting stars and comets. He measured the Egyptian pyramids and was said to have calculated the distance from shore of ships at sea using his knowledge of geometry. He also predicted an eclipse of the sun. He discovered 5 theorems like the triangle inscribed in a semicircle has a right triangle. And last, he was one of the 7 wise men of ancient Greece.
They developed a model for the solar system. The model assumes that the celestial bodies move in a circular motion. Also, the model introduced the idea that most celestial objects, including Earth, are spheres.
In 500 BC, the Babylonians were able to use the long record of observations to see regularities and patterns in the motions of the moon and planets. They repeatedly determined dates of the various configurations of the sun, the earth. From the dates, the Babylonians found each planet's syndonic period. They also discovered and measured the longer intervals of the time required for a planet to return to its same position. The discovery gave the Babylonians a simple, practical method for predicting the positions of the planets.
Aristotle was a student of Pluto, accepted model of Exodus, but modified it to have more spheres. He argued that all celestial motions must be circular because circular motion is the only motion that can be continued forever.
Aristarchus was a Greek astronomer who maintained that Earth rotates on its axis and revolves around the sun. He figured out how to measure the distance and sizes of the sun and moon. He deduced that the sun was so much bigger than the moon. He concluded that the earth must revolve around the sun. Aristoteles made the first measurement of the size of Earth.
Hipparchus proposed that the sun and moon traveled around circles rather than on nested spheres as other astronomers believed.
The Mayans studied the stars, planets, and the sun. Maya developed some of the most accurate pre-telescopes. Also, they created an accurate calendar and had a better estimate of the syndonic month than Ptolemy did.
He was known as mathematician, astronomer, geographer, and astrologer. He lived in Rome around 100 AD. His model of the solar system and heavenly spheres was way different from previous models developed by Greek astronomers. The Ptolemaic model accounted for the apparent motions of the planets in a very different way by assuming that each planet moved on a small sphere or circle called a ellipsoidal. that moved on a larger sphere or circle called a different. The stars, it was assumed, moved on a celestial sphere around outside of the planetary spheres. Ptolemy's model of an Earth-centered universe formed the basics of Arab and Islamic astronomy. The most valid reason that the Muslims studied the sky in so much detail was for the purpose of timekeeping. They are required to pray 5 times a day at specific points of the sun. By studying the sky, this was the most accurate way to determine when to pray, and was used to pinpoint religious festivals. Another important religious use.
Brahe proposed a model of the solar system that was intermediate between the Ptolemaic and Copernican models. His model proved to be incorrect. He made observations of supernovas too. He believed that the Earth was at the center of the universe. Brahe believed that the sun revolves around the Earth. Galileo made pioneering observations that laid the foundation for modern physics and astronomy in 1583. He entered the University of Pisa to study medicine. He soon became very fascinated with many subjects, particularly math and physics. In 1604, Galileo published the operations of the geometrical and military compass, revealing his skills with experiments and practical technological applications. That same year, Galileo refined his theories on motion and falling objects and developed the universal law of acceleration, which all objects in the universe obeyed. In July 1609, he learned about a simple telescope built by Dutch eyeglass makers and soon developed one of his own. Galileo's ambition pushed him to go further, and in the fall of 1609, he made the fateful decision to turn his little telescope towards the sky. Kepler discovered three major laws of planetary motions. The first law was that planets move in elliptical orbits with sun at one focus. The second law was the time necessary to traverse any arc of a planetary orbit is proportional to the area of the sector between the central body and that arc. And the third law was there is an exact relationship between the squares of the planets' periodic times and the cubes of the radii of their orbits. Kepler himself did not call these discoveries laws. He referred to them as celestial harmonies that reflected God's design for the universe.
He was an English scientist. In 1667, he developed three laws of motion that describe movement of objects in terms of force. All of the laws still hold true today.
He was an English astronomer and mathematician. He was the first to calculate the orbit of a comet. The comet was later named after him, Comet Halley. Einstein had many visionary scientific contributions, including the equivalence of mass and energy, or better known as E equals mc squared, and how the maximum speed of light affects time and space.
The discovery of electronic and radioactive led to different models of the atom. Niles proposed a theory for the hydrogen at based on quantum theory that energy is transferred only in a certain well-defined quantities.
In 1925, Pauli introduced two new quantum numbers and formulated the Pauli principle, stating any two electrons in an atom cannot have identical sets of quantum numbers. This principle applied to protons, neutrons, and the nuclei.
Warner discovered a way to formulate quantum machines in terms of materials. He published his uncertainty principle in 1927.
In 1923, Edwin Hubble discovered the Cepheid variables in the Andromeda Nebula, which resolved the nature of spiral nebulae. The period luminosity relationship for Cepheids helped him find the distance to the Andromeda Nebula. The distance was so far that it showed that the Andromeda Nebula and other spiral nebulae were beyond the Milky Way. They turned out to be other galaxies. Edwin's discovery uncovered many other galaxies, showing him we were not the only galaxy. George formulated the modern Big Bang theory, which states that the universe began in a cataclysmic explosion of one small superatom.
After Germany invaded Poland in 1939, Robert was administrated to a laboratory to carry out the Manhattan Project, the program that developed the first nuclear weapon.
Fred was a British mathematician and astronomer. He is best known as a foremost proponent and defender of the steady state theory of the universe. This theory holds both that the universe is expanding and that the matter is being created constantly to keep the density of matter constant. They accidentally discovered the cosmetic microwave background radiation in 1965. This is a major development in modern physics astrology. Armstrong and Aldrin were the first humans to step on the moon in 1969.